In this podcast episode, Dr. Daria Mochly-Rosen, a renowned mitochondrial researcher, delves deeply into the myriad of environmental and lifestyle factors that undermine mitochondrial health, accelerating aging and increasing the risk of chronic diseases. With a clear focus on actionable knowledge, Dr. Mochly-Rosen explores preventable mitochondrial insults, including smoking, air pollution, pesticides, radiation, stress, diet, and exercise, connecting these influences to broader health implications such as neurodegenerative diseases and overall aging. Dr. Mochly-Rosen opens the conversation by highlighting smoking as a prime example of a preventable mitochondrial insult. She explains that smoking generates harmful toxins like aldehydes, which are not unique to cigarettes, but also occur with alcohol consumption. These aldehydes oxidize mitochondrial proteins, impair their function, and induce DNA damage, contributing to cancer and other diseases. Importantly, she emphasizes that avoiding smoking is straightforward advice, but pollution and air quality represent more complex challenges as they are less directly controllable by individuals. Regarding pollution, including urban air contamination and prolonged exposure to smoke from barbecuing or campfires, Dr. Mochly-Rosen advises practical measures such as minimizing outdoor exercise during poor air quality days and paying attention to environmental factors like wind direction to reduce toxic exposure. She also highlights the role of advanced glycation end products, AGs, formed through charring foods or consuming ultra-processed crispy foods, which contribute to mitochondrial damage and aging. These compounds result from burned fats and reactive sugar protein products in food, and while occasional indulgence is fine, moderation is key to mitochondrial preservation. The dialogue touches on an interesting personal anecdote where the host describes experiencing brain fog after consuming fried foods, whether cooked in seed oils or beef tallow. Dr. Mochly-Rosen encourages listening to one's body, acknowledging individual variability and possible genetic predispositions in response to certain dietary fats. This reinforces the theme that each person may need a personalized approach to mitochondrial health, balancing enjoyment and caution. One of the more alarming environmental factors discussed is pesticide exposure. Dr. Mochly-Rosen characterizes pesticides as a man-made catastrophe that, despite boosting food production, negatively impacts human health. Specific pesticides interfere with complex, one of the mitochondrial electron transport chain, a critical site for ATP production. Epidemiological evidence connects lifelong pesticide exposure with elevated risk of Parkinson's disease through mitochondrial dysfunction, especially impacting dopamine neurons in vulnerable brain regions. She explains that the exact vulnerability of certain neuronal clusters to pesticides remains an open question, but suggests differences in neuron activity and supporting glial cells might explain selective damage. The discussion also raises the importance of protective policies and education to minimize pesticide exposure among agricultural workers and nearby populations, underscoring mitochondria as a key common denominator in environmental neurotoxicity. Radiation exposure, including UV light from the sun and medical imaging like X-rays and CT scans, is examined as a potent mitochondrial stressor. Dr. Mochly-Rosen elaborates on how radiation induces DNA damage and oxidative stress, similarly generating harmful aldehydes that overload mitochondrial detoxification pathways. She shares a key example involving a genetic mutation common in East Asians affecting aldehyde dehydrogenase 2, ALDH2, an enzyme crucial for detoxifying aldehydes. Individuals with this mutation experience heightened sensitivity to aldehyde-induced mitochondrial injury from alcohol, smoking, or environmental aldehydes, increasing risks for cancer, stroke, heart disease, and Parkinson's. Dr. Mochly-Rosen highlights how genetic variability extends beyond East Asian populations and stresses the importance of listening to bodily signals such as alcohol-induced flushing. Regarding medical radiation, she advises mindful use of diagnostic scans and preparation through proper sleep, hydration, and nutrition to optimize mitochondrial resilience. The conversation touches briefly on photobiomodulation and the complex effects of light on mitochondrial function, particularly through modulation of melatonin, a hormone synthesized in mitochondria and critical for circadian rhythm synchronization. While Dr. Mochly-Rosen acknowledges promising research, she underscores the need for more rigorous studies to clarify how exposures to various light frequencies and electromagnetic fields, including blue light from screens and Wi-Fi signals, truly affect mitochondria. Chronic stress emerges as a significant factor that detriments mitochondrial health. Dr. Mochly-Rosen explains that during prolonged stress, the body's mitochondria become overworked, producing ATP to sustain the stress response, diverting energy away from cellular maintenance and repair. This leads to accumulated mitochondrial damage and systemic exhaustion. She offers practical stress reduction strategies such as laughter, social connection, nature exposure, and avoiding excessive negative news consumption to preserve mitochondrial integrity even under difficult circumstances. Furthermore, she discusses compelling research linking mood states to mitochondrial damage biomarkers in caregivers and explores the dynamic interplay between mitochondrial dysfunction and telomere shortening, the protective chromosome ends often considered markers of biological aging. Healthy mitochondria support telomere maintenance and vice versa, revealing a feedback loop integral to aging and stress resilience. Exercise is repeatedly emphasized as a powerful intervention to bolster mitochondrial function. Dr. Mochly-Rosen explains that both endurance and strength training contribute uniquely to mitochondrial health. Endurance exercise promotes mitochondrial biogenesis and the selective removal of damaged mitochondria, mitophagy, while strength training increases muscle mass, thereby expanding total mitochondrial content. During exercise, mitochondria produce small peptides, such as humanin, which have systemic benefits including neuroprotection. These exercise-induced peptides mediate communication within cells and to other tissues, highlighting mitochondria as central orchestrators of whole-body health. The discussion also touches on exercise-modulating reactive oxygen species, or OS levels, traditionally viewed as harmful but actually crucial signaling molecules that stimulate mitochondrial renewal. Nutrition is recognized for its crucial impact on mitochondrial function, with a special emphasis on fiber intake as a prebiotic nourishing gut microbiota that produce butyrate, a short-chain fatty acid vital for colon health and systemic mitochondrial support. Inadequate fiber can thin protective gut mucus layers, leading to inflammation and secondary mitochondrial stress. The conversation explores fasting and calorie restriction, highlighting promising animal studies showing lifespan extension, though human data remain complex. A key takeaway endorses the importance of metabolic flexibility, allowing mitochondria to switch between glucose and fat utilization by limiting eating windows, avoiding continuous snacking, and reducing caloric excess. Dr. Mochly-Rosen advocates balanced, varied diets rich in micronutrients for optimal mitochondrial enzyme function, cautioning against extreme or single-food fads. Dr. Mochly-Rosen expresses optimism about emerging mitochondrial medicine, including peptide therapies mimicking endogenous mitochondrial peptides like humanin. She highlights an exciting frontier involving mitochondrial transplantation, where purified mitochondria from healthy tissue are injected into damaged areas to restore function. Animal and early human studies show encouraging results, especially for heart repair, though mechanisms remain to be fully elucidated. Artificial intelligence is anticipated to aid mitochondrial research by handling vast datasets, predicting protein structures, and integrating complex biological systems to accelerate novel therapeutic discoveries. Yet, she insists AI will complement, not replace, the creative insights of human scientists. Concluding, Dr. Mochly-Rosen emphasizes the empowering message that despite mitochondrial vulnerability to numerous modern insults, individuals can regain a degree of control through lifestyle choices and emerging medical advances. She advocates for patience and self-compassion, urging listeners to take manageable steps, such as quitting smoking, reducing exposure to toxins, managing stress, eating a balanced diet, and exercising to support their mitochondria and overall health. Her work and book, The Life Machines: How Taking Care of Your Mitochondria Can Transform Your Health, serve as guides to navigating these challenges, combining cutting-edge science with practical advice for readers seeking to age healthier and live fuller lives.